So the topic was an invoice parser in Python, and we did that during our regular sprint, which took place at Chivago's office. And the reason why I did that is that we have a box at home with a huge number of invoices, or receipts as they call it. And the problem is that we try to keep our housekeeping book in sync with that. So we try to write down the supermarket name, the date, and the sum of the receipt, and then calculate the sum after each month, so to get a little overview of what we spent and how we spent it. And I was a bit sloppy with that, so I don't keep up with it, and so the amounts of receipts, it grew, and then it filled that box. And I said I need to do something against that. So the idea was to make a machine do it, because I'm just too lazy for it, and actually I also make a lot of mistakes when I try to write it down correctly. And actually I wanted to see how good a machine can be in that task. So it turns out I can use that as unit tests. And I just need a little scanner, which you can see here. That's the scanner device. I had it lying around at home, and it was collecting dust, because I was never scanning anything, any photo or something, so maybe I could use that, I thought. And then I made it as simple as possible, so I used my laptop here to write some tool for it. And when I started with it, I had no clue which library to use or how to do it. The original plan was to measure the distance from the top of an invoice until the supermarket name. So because it's always a fixed distance from the top, and you can say, you can take this as a header, and that header can be compared to others, to other headers from other receipts that you already parsed, and say, okay, if it is similar, then it must be that market. Turns out it's not that easy, because there are many edge cases, and if you want to do image recognition, it is very hard and also very time intensive. Maybe if you want to try it on a Raspberry Pi, then you have a hard time. And the second thing is, you don't want to do that, because you need to put it into some configuration file and keep that updated, and whenever you have a new market, you need to write maybe a new configuration file for it. So it should work out of the box magically, and it should work reliably as well, because everything below 90% of hit rate is useless. I could do it by hand then, instead of fixing the tool. So it needed to be quite accurate. So the idea was to do it in a fuzzy way. And that picture is not there by coincidence. So regex parsing is not fun. Or it can be fun, but it needs a lot of trial and error, and especially when you deal with fuzzy data, it can get tricky. So why do we need to do regex parsing? Because in a perfect world, what you could have is just your input, which would be an image, and it would be perfectly readable for a machine, and then the output would be text, and then you can just read the text and match it directly. So I'd like to give you some examples of the invoices that I parsed, and maybe then you can see why this is not so easy. So first of all, a scanned image looks like this. so it was rotated. So you need to rotate it, of course. And since that little scanner was always scanning it with the same rotation, then you can just rotate it by 45 degrees, and that's basically 90 degrees, sorry. This one is a very good example because you can see the market is, you can recognize that, you can see the sum is easily recognizable, and the date is also somewhere. Where is the date? Here. This is also where it gets tricky because a machine does not see this. A machine makes sense of this. And if you go here, this is where it gets a little fuzzy here. So gaps in numbers also are tricky. But this is a very good example, and it was working without problems. But maybe look at this one. Okay. This one is good. What about this one? I'm trying to open it. Oh, because it's here. You can see some problems here. Not particularly with the bar or with the sum or the date, but at some other places, like here, it gets very fuzzy. And you have many cases where I had very old invoices. We can maybe skip through the list a little bit and check it out. Let's try this. Something like that, where your image is a bit tilted or so, it's screwed up, so you cannot really read what is on there. Maybe the date is missing. Here also, what we want to match is okay, but we might have problems with the supermarket name here. So to make that a little easier for me, image parsing itself is not done by me, it is done by Tesseract. And if you haven't heard of it, it's super awesome. It's a Google project. And what it does is exactly what I want to do. It has an OCR engine, and it has support for many languages. And you give it an input image, and it returns an output text. So this was developed by HP in the 80s and 90s, and then Google took over. In my opinion, they did it because they were doing a lot of OCR while scanning books. So I guess they looked around for solutions that were already available, which makes a lot of sense. And they they are very strong contributors. What comes out of it is something like this. This is matching German already. So you can see this like here, where it matches Reue instead of Rewe. And also some other things are not well discovered, but mostly this was okay. We have much worse examples here. This one is also okay, but sometimes it happens that some letters, some important letters are wrong. Like here, this should be Aldi, so you need to match it in a very fuzzy way. Also here, a human, I guess, can read it. At least a German human being can read that this should be Sum here, Summe, but a computer can't possibly read that as Sum. So what was the approach? First of all, I wrote that import script, and what it does was the steps that I explained already. It is rotating the image, then it does some pre-processing, like improving the contrast and sharpening the image, also leveling the image so that it has equal brightness. That step was very good. because it improved the success rate a lot. And then it does OCR recognition, and this is a to-do. I didn't touch the script after the hackathon, so if it is not matching the text that we expect, then we can do maybe some later processing as well. Then the parser script. I can show you that script maybe in text editor. It is super simple. But I guess Atom has a different opinion. Yeah, that is the whole script, so don't ignore that. On the left it's another project, but this is the whole script, all that it does. And this is a regex to match dates, and maybe you can't read it, but the date format is something like day.month.year, and in all different combinations. And I tried to make it a little simple. Is that it's not here? Still loading. Where is the? Try to use a tool called regex 101. Anybody heard of regex 101? I would love to show you, but it's kind of slow. But I have another image here. I'm gonna search that image for you because it is interesting to see how I was trying to match the regexes. So here it is. And this is the regex in a slightly modified form, the regex that you saw already. And here are the matches. So I did not use a test framework for date matching. I just used whatever I found and put it in here, and also included some failure cases. And in the end it was pretty okay. So it was always using the first entry it found in a receipt, and it matched like those two here, but it was using this one because it was the first. And usually the date comes in front of the time, so that was okay. For matching the supermarket, what I did was just having a list of supermarkets, and this list is matching what I use. This should go into a YAML file, and also this maybe should not be there. I'm pretty sure it's not even needed anymore because fuzzy parsing is better with a function that I will show you in a second. But another heuristic that I used was if I can't read the market name, maybe if the header of the receipt is missing, then I can still try to figure it out if I can fuzzy match the street, because I know some markets and the street name where they are located. And I did the same for the sum. So these are just some terms for sum in German. And parsing it with that is very quick. It can go very quick. If you have a direct match, great. If not, then you use that fuzzy find method here, and what it does is it uses a library called getCloseMatches from the difflib library, and it gives me the best match with a certain accuracy, and this is just a wrapper around it. So I just was running through my unit tests, my receipts that I scanned, 127, and 127 received. And I was playing around with that accuracy, and it gave me the best hits with that, so I just went with that. And that's basically it. So I have a statistics file where I was keeping track of the stats over time. And it was a bit sloppy as well here, because I did not put in every step. But most of the other steps are basically tweaking of the changes that I did here. So for instance, if I add Aldi, then maybe in those steps I tested it out and add another way of writing Aldi, maybe in capital letters, or maybe with spaces in between, or maybe with some fuzzy matching. And then I created a graph out of it. And that is the success rate, at least until the end of the hackathon. So you can see that the date, I started with the market name. So that's why in my first tries, at the bottom you can see the runs that I did. In my first runs, I tried to only improve the market name detection, and then that little dip here, it was because I had a programming error and it was throwing an exception, but it was still writing the statistics. So the exception, you can see where it was thrown. It was thrown around receipt number 10 that it was trying to match. So this is the little dip. It's in reality it's not there. And then at the end I tried to also work with the dates, the date text. Maybe if I'm lucky, you can already see the updated version of that. I'm not lucky, so I will go to the success rate here. Yeah. So after the hackathon, I played a little bit more with the tweaking. I had one day where I needed to do a train ride, so I was doing that on the train ride, and you can see the matching is kind of accurate for the market now, but still did not have much time for the rest. But I'm pretty sure that you can go up to the same level, and it's working pretty well for me. And if you want, you can use it. It's on GitHub, and you can contribute to it. There's also the blog post about it, and there's many other tools similar to it. You can find them on Hacker News. Future plans. I'm not 100% sure if I ever will touch this script again, but if I will have the time and patience to do it, then I will try to analyze the error cases a bit more. This image pre-processing task, yeah, also nice to have. Also adding more unit tests, but maybe also porting it to Tesseract and using a real Raspberry Pi for it and not my MacBook as it currently stands. And maybe also do some profiling, because I'm really curious on how fast it can go. But apart from that, I guess it's in a usable state, so why change it? And yeah, that's it from my side. Question?